Hi everyone. So today we are going through the prediction market Dapp. So we'll go through what is a Dapp, and then we'll understand the Dapp architecture and also understand about the prediction market application. And we'll also go through the code flow by deploying a smart contract and how to interact from the front end. So I'm Praveen. I've been into Kaia since 3 years. So I'm a senior blockchain engineer. So I'm majorly working right now in ecosystem. So which means like whatever we need for Kaia blockchain, be it like SDK development or integration with the partners, I mainly involved in that area. So I think we can directly jump into the topic. Yeah, so we'll mainly cover these topics like what's a Dapp architecture, some of the dev tools. We'll understand what kind of dev tools we're going to be using as part of this Dapp creation. And we'll understand about the prediction market application, what it does and what kind of features we can add, and mainly the architecture. So whatever we have discussed as part of the Dapp architecture, we'll choose one of that and we'll use in the prediction market architecture, and we'll try to go through the smart contract logic for the prediction market, and we'll also see how the front end interacts with it. And finally, we'll have some discussion on the exercise and Q&A. So first of all, what's a Dapp? So we've been hearing about the Dapp a lot, like in the blockchain space, we've been hearing about the Dapp, but does it mean that any application which interacts with the blockchain, do we call that's a Dapp, or like does it have any criteria? So generally a Dapp means a decentralized application. So we don't have to call every application whichever interacts with the blockchain as a Dapp. So generally there's a certain criteria that a Dapp has to follow. So for example, like one is the decentralization. So mainly the core functionality of the Dapp, be it like maybe when you're building a voting application, or be it like maybe a supply chain or anything. So the core logic of it should not be centralized, should not be located in a centralized server, which means the logic has to be in a decentralized way, either maybe in a smart contracts, or the code has to be like easily transparent for the user. The second criteria is maybe the open source. So the code has to be open source so that every user, whoever is trying to interact with the Dapp, with the smart contracts or with the logic, they need to know what kind of logic it's written in the business. And the third one is like, of course, when you use mostly the smart contracts, all the core logic is kind of a transparent for the user, and he'll be knowing the number of transactions that happens on the smart contracts, and mainly the incentives and the tokenization. All this generally a Dapp has, and there shouldn't be any central authority. For example, maybe if the users try to interact with an application, let's say if it has a central authority, and if because of some means, let's say if that central server gets down, or because of some means, let's say uh, there's a transaction, or there's some kind of weird transactions happen via a centralized server, then this kind of there should not be any central authority. That's the main idea. So the user should have the core control on the business logic. That's a main feature, or that's the main criteria for saying an application as a Dapp. So now we'll go through the Dapp architecture. So maybe, yeah, so here I've provided a different type of application. For example, maybe if you just see a basic Web2 architecture, so we'll have a front end. Maybe I'll just show this one in editor. Yeah, so if you just go to a Web2 architecture, like a very basic application, so majorly we'll have a front end and we'll have a backend. In a backend, there'll be some business logic and the data to be stored in a database. So this is a typical Web2 architecture. But in Web3, we'll be using blockchain, of course. But here, from the front end, we can either interact with some kind of wallet management services, or we can have our own wallet management services where we have the private keys of the user. And from through that wallet management services, we kind of communicate with the blockchain. So that's a typical Web3 architectures. So in Web3 architectures also, we could divide into two types. So one is centralized application, Web3 architecture, and one is decentralized apps. So in a centralized apps, normal users, all the users interact from a front end to some kind of a central backend logic. So, and through that central backend logic, the blockchain interactions happen. So in the backend logic, there could be a key management system, and it can have some kind of business logic, and there could be a smart contracts which is deployed on the blockchain. And this is how the centralized applications work. So here, for example, the main authority will still be with the centralized application providers. For example, all the companies like Binance, or like, let's say there's some trading companies, or there could be any applications. So all the central logic could be with the service providers itself, or the control would be with the service providers itself. So the user need not to be worry about the jargons of all the blockchain things, and it will be an easier way for the user. But on the other side, he'll lose the control on the entire assets that he has, or entire data that he has. He'll still lose the control, and the control is given to the provider. So this is mostly the centralized applications, and of course, in different sectors, like maybe trading companies, or they could be any kind of maybe supply chain applications, or any kind of applications. They are set of centralized applications as well as decentralized. So, but in the decentralized applications, the user still can interact from a front end through via a wallet, where he'll have more control on the private keys. So when the user has the control on the keys, that's when he'll have the control on the entire assets that he has. So in this scenario, in this framework, as you can see, the users interact to the backend logic, or to the blockchain via the wallets. The wallet could be, there are different types of wallets. It could be a custodial, non-custodial, or like MPC wallets, which also is kind of a non-custodial wallet. So so here in this scenario, if you see, even though there could be some business logics on the backend, but that doesn't have much control, or the service providers will not have much control on it, or the central logic is not present in that particular backend. So the major control would be in the smart contract logic, where the user can directly interact to it. Maybe if the Dapp goes down, or if this application goes down, user can find other means, or another easiest ways, maybe like getting an open source code and maybe interacting with it. So this a difference between the centralized applications and decentralized, even though there's a blockchain component in it. So here at different levels, we could use a different set of technologies. So that, for example, like front end, you could use any kind of frameworks, React.js or Angular. And to interact with the blockchain, you kind of use some libraries like Web3.js, Kver, Vim. So all these are libraries which is useful for you to interact with the blockchain. So in the blockchain, maybe if you want to do a value transfer, or when you want to transfer your assets, or if you have a smart contract logic in the backend, and if you want to interact from a front end, then you kind of use this kind of libraries from the front end, or you can also use these libraries from a backend as well. And you can have some business logic, which is helpful for the Dapp to progress. And from the wallet interacts to something called like URLs, RPC endpoints. So these URLs are like an entry point for you to interact to the blockchain. So there are different type of URLs, be it like free services. There are free RPC URLs, which most of the foundations or the companies provide. They are not reliable, majorly for the production, it might not be suitable. But when you go for production grade services, then you go for paid services, paid RPC URLs. So instead of so they could you can go for any paid services. So they will give you an endpoint with an API key, which you can configure in your application or in your wallet providers, and you can communicate to the blockchain. Or the final thing is, you can also host one of the endpoints and connect to the actual network. So for example, if you are having a kind of a gaming company, which you might need even better performance. So these kind of stuff, lot of companies, they kind of host their own endpoints. And maybe if you want to host your own Explorer. So Explorers kind of have it kind of has to interact with the blockchain a lot, and they could and it needs to have a very good performance. So in that scenarios, people go for having their own endpoints. So in this way, people can have different ways of RPC endpoints or different ways of these kind of URLs for communicating with the actual blockchain. Yeah, and on the blockchain, of course, you can develop the smart contracts. And for smart contracts, for Kaia, you can use Solidity language. And there are some set of tools, which are developer tools, which are useful for you to deploy, test onto the Kaia network. So this is the overall architecture of it. And moving on. Yeah, sorry. Yeah, maybe I'll just go here. So here I've mentioned all the different type of tools that are required for a Dapp development, or even a centralized application as well. So majorly on the blockchain network side, Kaya has mainnet, testnet, and you can run your own private network. If you're creating your own use case with to have your own blockchain, you can still host your private network, or you can even connect to a test network for majorly testing your application. So you can get dummy tokens or dummy coins, and then you could actually test your application before going to the production. So mainnet is kind of a production network where you have the real money over there. And you can on the block after selecting a blockchain network, of course, you can have a smart contract. So for smart contract, for Kaya, you can use Solidity language. And for writing the smart contract and deploying the smart contract, even writing the test cases of it, you can use some of the frameworks like Hard Hat, Foundry, and there's also some IDEs that you could use. One of the well-known IDEs, Remix IDE. You can also find an online browser of it. So you can write the smart contract in the Remix IDE itself. As part of this example, we'll be using Remix IDE. We'll actually deploy the smart contract from a Remix IDE. And RPC and URLs, like I said, there are different sets of RPC URLs that you can choose. Majorly for testing and for local, maybe you can just try out the free public endpoints. And when you go for the production, you can have the other ways of communicating with the blockchain. And wallets, there are different type of wallets. Majorly wallets are used for storing your private keys or the keys. So with which you can control the assets. So you can store, manage, you can also send and receive your assets from that wallet. So these wallets can be divided based on various factors. So one is through the platform. So in the platform, you can have mobile wallets, desktop wallets, and also hardware wallets. Like for example, in the Chrome extension, you can install a wallet, for example, be it like Kaya wallet or MetaMask. You can also have a similar kind of wallets in your mobile. And there are some of the wallets which is a hardware and which is disconnected from the internet, and you can actually connect via Bluetooth or anything when you're performing a transaction. So and based on the internet connectivity also, you can segregate the type of wallets, like hot wallet and cold wallets. So if you are in your application, if you are using a particular wallet for every now and then you can name them as hot wallets. And if you separate it out and then use rarely, maybe you can name them as a cold wallet, like be it like hardware wallets. If you put it, then maybe if you have very less interaction and if it's separated from the internet, for the safety purposes, you can go for the cold wallets. And there's also some of the types of wallets like paper wallets where you can just generate mnemonic whatever you want on a paper and like just write down on a paper and put it with yourself. And there are some of the wallets which are divided based on the custody. So for example, like the companies like Binance or the Coinbase, all these are like a centralized applications, even though they interact with the blockchain. So they hold your private keys. So the user need not to know or need not to handle all these private keys, or he need not to safeguard those private keys. So you can just log in maybe with your email and have a two-factor authentications for it, just like you have for a normal banks. But there's also another types like non-custodial wallets, like for example, all this MetaMask, and they are like some of the hardware wallets and software wallets. There are some non-custodial wallets, which means you maintain the private keys. So suppose, let's say, like if I have a private key here and by mistake, if I just uninstall without any backup, then you kind of lose all your assets. So you always have to make sure your private key or the mnemonic of your wallet is safe, and you also have a good backups, maybe in a like a silver plates or maybe in a hardware wallet somewhere which is safer. So so there are these types like custodial and non-custodial. So as part of this, we'll be using something called as Web3 Auth, which is a MPC wallet. So even there's a company where they kind of store the private keys, but they'll not all the private key is not stored in a single machine. So it's divided into multiple pieces like shards, and then it's stored in different places. So when the user try to connect with that wallet, all the shards, few of the shards come together and form a private key in the front end itself. So it's kind of a safe architecture, which MPC wallets use. So Web3 Auth is one of those kind of services. And there are different type of libraries that you could use based on the framework that you have, maybe Java, Python. So based on the language that you choose, there are different set of libraries which you could use for communicating with the blockchain. So once you have the smart contracts ready, and then once it's deployed to a blockchain, then you might have to communicate with that blockchain, with that smart contract. So for that, you might have to go with any kind of libraries. So a few of them are like Web3.js, Ethers, and even Kaia has a Kaia SDK, which has the Kaia specific features. So under Kaia SDK, there are set of Web3 extension, Ethers extension, Vim extension. These are like some of the extensions which Kaia team have put on. So this mainly provides some of the features that other blockchains doesn't have. And then if you want to go with Java, there are like Web3 Java, and then Web3 Python, and also Flutter. There's a library. In this way, there are different set of libraries for based on the language that you choose. And there's also like some of the APIs that some of the service providers give you. So a few of them like Cars, Infura. So these type of companies, they kind of provide you APIs. So you don't have to understand each of the framework and understand what kind of functions it is. So most of these APIs are like very easy for a normal user to go through and then use it. And once you have this library study now, like once you have this, like now where should I get the coins? Maybe like when you are deploying a smart contract or when you are just testing out, you might need some kind of like some coins to have maybe when you're deploying in a mainnet. So when you are going for a mainnet, you can buy the coins via various platforms. Like maybe you can go to Binance, which is a centralized exchange. You can go there and pay via your fiat money, maybe USD or any other currencies, and you can get Kaya or ETH, maybe BTC and all this stuff. And there's also some of the solutions like on-ramp solutions like Alchemy Pay and MoonPay. So there are like lot of these type of on-ramp solutions where you could directly go and fill your KYC if needed, and maybe finally you can get the coins directly to your wallets. And for test tokens, there are like lots of faucets. Even Kaya has a faucet. So I gave a link here, and we'll be using that. So it's you can directly go there, paste your address, and you can get your test tokens. So as part of the Kaya, so Kaya provides 50 test tokens for you, which is like plenty of test tokens for you to test, and you can play with it. And finally, we also need to just understand what's an explorer. So finally, once you have all this things ready, and when you make some transactions, if you want to get a snapshot of a particular account, or if you want to go through what happened to it and what kind of assets you have received or sent out of your wallet, then you can go to these type of explorers, and you can just paste your address over there, and you'll get the entire history of it, the total transactions that you have, the incoming or outgoing assets that you have. So all this information could be visible in the explorers. And you can also see all the block information, even the transaction information. You can also see the raw data, what kind of raw data the user have passed when he was trying to communicate with a smart contract. So that's why, like, when we are writing some data into a smart contract, we should be careful, because most of the public blockchains, every data, whatever it's written into the blockchain, is kind of visible to everyone. So of course, as part of this, we'll be using Kaia scan. Kaia scan is one of the explorers in Kaia. So until now, like, anyone has any questions? Yeah, for sure. I think maybe if you have any questions, yeah, sure, please drop into the chat. Maybe finally we can go through them. So now let's jump into the prediction market. So prediction market application is just a platform where users can bet on the future events. Like, for example, you can just create an event like what happens in the next 5 years, or what happens at the end of this year, or who wins a particular election or anything. So this could be some set of events that people can create, and upon that people can purchase the shares. Like, they can go for yes or no on that particular prediction. So based on that, if the prediction, once it resolves, finally people could earn some money out of that. So some of the events could be like elections. People can also create some events or the markets for financials. Like maybe S&P index after a particular year, can it go up to this or less than this? And you can also have an events related to sports or pop culture. So there are like lots of events that you could create. Maybe will there be a Marvel movie in the next 2 years, or a better movie, something like that. Maybe you could create like any kind of events that you want, and people could actually bet on that particular event. So this is the the basic definition of a prediction market, and there are like lots of prediction market related applications. And how it works. So actually, once a prediction event is created, user actually bets or trades the shares based on the outcome. So he'll just buy, or he'll just go for a yes or no on that particular prediction. And once you have it, like mostly some of the applications could have a simple binary like yes or no, saying yes or no for that event. Or there are some applications which is different than a simple binary. So once you have that, so there would be a nominal fee for every kind of prediction. So let's say there's an event and you might have to say yes, you could say yes for like 5 times. And for every nominal fee, they could have like $1 or so, or $1. It could be an equivalent to a token, or it could be an equivalent of a dollar. And you can buy as many as you want, or you can also restrict based on your use case. And once you have it, finally, once you get a prediction outcome, the holders could actually get the rewards. So, for example, let's say finally the outcome is yes, all the money of the persons whoever voted no, all the money should be distributed among the people whoever goes to the option A. So, and there are like different models out of this prediction markets as well, like fixed model. One is a fixed model where you have like yes and no, and then you also have set a minimal nominal amount for each and every share that people buy. And there are different other type of models like order book model, where once you have an event, people could actually buy shares. They can define the amount whatever they want, and they can vote for maybe yes or no accordingly. And there are some set of models like AMM models, where they could add liquidity also to that particular event. And finally, when the closure comes, whoever has finally the value of that particular event defines the success rate of that particular event. So these are like different types. And of course, as part of this, we'll go with a simple fixed model where we'll have yes or no types, and we'll also set a cost or nominal amount for each and every share that we have. that a person buy or sells. So here there's an example, like as part of the fixed example, a fixed model, we can go for every share, we can have a minimal amount like $1, or you can set how much ever you want. So as part of our example, we'll go with like USDT also. And finally, once there is a winning option, you can finally split all the losing option related money to the winners. So here there's an example, like let's say user one buys 20 shares of option A and user two buys 10 shares of option A. And there's a user three who went with like 50 shares for option B. And this is like a general formula. So finally you'll find a ratio. So you have 30 shares on option A and 15 shares for option B. So it's kind of a 0.5 ratio for this. And for example, like finally, once, let's say if the option A won, so you kind of do like a 20 plus. So you'll just go with the formula saying like, I think there's a minor change in this. So this is just a profit of it. So you kind of go with a 20 into 0.5, which is like 10. And then you also add with the user shares. So for example, the option A would get like 20 plus 20 into 0.5. So finally he'll get 30 as a return. And then user two would get 15 as a total return. I mean, along with his initially invested coins. So this is like a general fixed model. So yeah, so now I think we'll go with some of the internals of how to have the market flow, what's the market flow, and how to organize the things. So now we understood like Polymarket has different set of events. So you can call every event as a market. So now in the Polymarket, you have different type of markets. So you can name everything as every event as a market. So you can define every market with a basic structure. So the market can have a question. So because you are kind of creating an event saying, can this stock, maybe like can a particular ABC stock, can it go above $1 in this year or so? Maybe you can have that kind of questions. And then you can have two options, option A and option B, and people can purchase these options or can actually invest into these options. And finally, there could also be a resolve outcome. So once the investment is done, and you can define an end date for that particular event, and once the event is done, finally the admin can choose the outcome. Maybe the admin, or it can be even automated, maybe based on the APIs. But let's say like if an admin chooses the outcome, like option A or option B, and finally based on the winning option, you can actually flip the status. So this is like a basic market, like the variables which are required for the to define an event. And you can define different stages of this event. So initially, as soon as you create an event, you can have that as an active stage. Then you'll have the end date as not expired because it's still active, and people can actually purchase the option A and option B. So you can create two options, and people can actually put the money into it and buy as much as they want. And once this is done, let's say if it hits the end date, then it goes into the second stage where it has an expired date, but the outcome is not resolved, which means the admin hasn't updated the final winning option. So this could be a second stage where you can have it, it will be in a pending state. And finally, let's say if it has to go to a third stage is when the admin actually puts the result into the application. So this is a third stage where the end date is already expired and the outcome is updated. And once the outcome is updated, now user can actually perform the claims. They can claim the winning amount from the investment. So this is like an entire flow of the event in the market flow. So yeah, if you have any questions for this, you can just, I think when I show the application, you'll just understand how we are connecting the stage 1, 2, and 3. So I think now we can go through the code demo. So this particular example is already committed into the GitHub, so you can just go and grab that. So as part of this, maybe first I'll go through the Solidity part. Yeah, sorry. Maybe I'll just open the remix ID itself. So as part of this example, whatever we are investing is in the form of some tokens. So I just created a basic token structure, which is USDT. I just named it as USDT. So you can create these kind of a basic structure. So you can also get some kind of sample code from wizards also. Like we already have wizard.kaia.io. So for example, if you want to just deploy some kind of KIP7, which is equivalent of ERC20. So if you want to deploy a ERC20, you can just select the options which you want and you can open in Remix. So similarly, I have created a basic structure for it. And as you can see, as part of the constructor, I gave a set of coins here and I'm minting to the current address itself, which means that as soon as we deploy this contract, this many number of tokens is actually sent to the contract itself. So it will be located within the contract itself. And then I provided a claim function. So this function is for any user to come and then maybe withdraw the tokens. So they can, this claim function is just for, maybe they can just withdraw the tokens. Maybe for example, if I just deploy this application into a server, and if I want to provide a dummy tokens for the user to interact, I think this kind of function will be useful. So I just provided a claim function where a person can directly go and click on that button, and then he'll get some kind of like at least 1,000 tokens into his wallet directly, because we are directly deducting this amount from this native USD itself or this deployed contract itself. So I'll just show this function also, like where exactly I'm using it. And then, yeah, let's go through the prediction market. So like I was explaining, first we need, so in the prediction market, like I was saying, we have multiple markets. So first we need a mapping. I think you must have learned about the mapping in the previous sessions. So first we need a mapping which stores the list of all the markets. So here, this is just a mapping, means this is just like a dictionary. So where you have a key as a number and then the market information as a value. So for example, maybe you can just add how many number of markets you want. So here I'm maintaining a list of all the markets. And this market data is here. As you can see, this is a struct data type. And we need a question. So because like whenever you create an event, you need to have a question. And there's also an end time, which is defined. So, and then there's an outcome. So once you have a final output, maybe the admin will provide the outcome, whether it's option A or option B, the winning part. And then the option A and option B, you can give the names for it, like yes or no, maybe like maybe some other thing, A or B, something like that. You can give any names for option A and option B. And these are number of shares that people invest in. So these are the tokens, like kind of a tokens that people actually put into this. So uh, we are tracking over here. And then we have for each and every address, we are maintaining here. So we have option A shares balance. So for every address that whoever puts the money in, we are tracking that as part of a mapping over here. So for option A shares balance, we are maintaining address and also the balance of how much money he have put in. For the option B as well is the same thing. So and finally, once it reaches to the final stage, the stage 3, people can actually claim the tokens. If he has a winning option, then you can do the calculation and then finally people can claim and we'll just maintain whether you have already claimed it or not. I think this final step is mainly useful for you to show in a front end or something.
Hi, Praveen. Sorry, I think there are people in chat who's asking if you can maybe zoom in a bit for in this screen.
Yeah.
Is that a bit better,
This
guys?
is
Okay, yeah, it works. I know I said I ask all questions at the end, but will there be a form for submission at the end of the class?
Yeah, there's a form which will be shared in the Discord. I think AO might help on this. he'll share on the Discord. I think I have defined the exercise at the end. There's also an exercise, which is a kind of similar application.
Yeah, so essentially, don't worry, guys. All the slides and the recording will be shared probably sometime maybe later today or tomorrow. And the thing is, I'll try to get the recording out as soon as possible because the next class is actually tomorrow as well, the back-to-back classes. I'm sorry, but that's because mostly because of the town hall that's happening on Thursday. We don't want to clash at the same time. So yeah. Anyways, yeah, I'll leave you to it, Praveen.
Yeah. So we have seen some of the variables of the market, mainly the question, the end date of that particular event, and the outcome. Like I was saying, the outcome is an enum. So outcome could be the final answer of that particular event, whether it's option A or option B, which is decided by the admin. And then this is the enum. Yeah. So now we went through the market list. Yeah. So now we went through all the markets, like how to define the markets. We are also just maintaining the market count, like how many markets we have in this entire contract. And then we also configured a betting token, which is the token which people invest with. So as part of the event, maybe people have to invest with a particular token or maybe a native coin as well. It's based on your implementation. But as part of this, I have added a betting token, which is a ERC20 standard. So people can actually invest with this particular ERC20 standard. So now we understood, like we have the markets, we have the structure of the markets, and we also have like status of that particular market. And then now I think we can see how the market is created now. So there's a function called create market. So as you can see here, I think this is only created by the owner. So, I mean, it's up to you how the implementation has to be done. So majorly the owner, or maybe you can also get the money from some people, maybe like huge money, like little bit more than whatever it's done for the betting. Maybe the person, if they invest like maybe 1,000 or like maybe $20 worth of USDT, then maybe a person can create his own market. So in that way, I mean, you can create your own. It's up to the use case of the application as well. So, but here in this case, as you can see, only the owner will be able to create an event. And there's also a duration. I think these are like basic checks. The main thing is that here, as you can see, that this is markets is a mapping. So we got the mapping data here, and then we gave an ID. So this ID is just a counter. So let's say like initially if it's 0, you are just increasing the counter of that market count, and then you are incrementing the market ID, and then you are storing into this market. So majorly you are just kind of initializing the market object here. So you have a market and whatever user passes into this object. So question is in the form of string, option A and option B, you are naming them, like maybe option A or option B, or be it like yes or no. You can name the options. So here the options, the names of the options are also stored here. And there's end time. So this end time is just like, let's say the event, maybe you created the event only for 1 hour, it will just check based on the current block. So for the current block timestamp, it will add 1 hour duration. So this is in the form of seconds. So the duration you'll forward to the function in the form of seconds. So for the current block, so whenever you are actually creating the event, so at that particular time, plus whatever duration you have forwarded, let's say you have forwarded 1 hour, so it will store that entire data into the end time. And then the final outcome. So the when you are initializing the market, you'll just give unresolved, which is a default outcome enum. And finally, you can also emit an event and you can listen later. And you're also returning the market ID. Yeah. So majorly the create market will add a particular market object into the market list, into the market mapping. So here, this particular data is added into the market mappings for this particular ID that you have given. So once you have the market ready, now people can buy the shares. So this is just a buy function where people provide the market ID. So which is the default there's a counter for every market. So there's an ID, people forward that ID, and also the option for which he wants to buy and the amount he wants to buy for that, wants to invest in that particular option. So these three values you forward into it, and you kind of get the current market information, you do basic checks, and finally you also like transfer the data. As you can see, you are transferring the money into this market, into the like investing into the event. So from the sender, you kind of sending to the contract itself and this amount. So this is the transfer function which we are using here. And finally, like we are also maintaining the options balances for each and every account, each and every address. So for that, we are adding into the mapping of it, like for in the left side, if you see the person whoever calls, he is referred to message.sender, and then the amount whatever he forwarded is added there. So this maintains the mapping for the individual person whoever puts the money in, and the total amount is added into the total options. Similarly, like we invest in the option B, I think it will just go into the option B's mapping, and then you are adding the total balance to the option to the B shares total options. And you can also emit the event with a market ID and like whatever data you want to track. And once all the users have bought the shares, and once it passes the end time, the end date, then the admin could actually involve in, and then he can resolve the market. He can actually provide the answer for that particular event. So as part of this, he'll just provide the market ID and final outcome. Outcome is just option A or option B. So for this, here are like basic checks. This is done by the admin. So here are the basic checks. It also checks the end time based on the configured time. It checks whether the current time have already passed with the end time or not, and if the market have already resolved or not. So these are like some of the checks which is done, and finally you'll set the outcome and make that event as resolved, because that's when like you reach the final stage. So this is the final stage, and once that is done, now users can actually claim the winning. So every user, whenever he claims, he'll just provide the market ID, and then like we discussed, I think these are just sorry, I think this is the reward ratio calculation which I was talking about. So the user shares plus user shares into the reward ratio. So this is a main thing. Yeah, this is a logic that you could use for getting the winning amount. And finally, once you get the winning amount from this particular contract, you kind of send that amount to the to the person whoever called the actual winner, the user itself. And finally, you can also emit the event. So these are mostly the write functions. So like whenever you are in the state of the particular function of the data that you have. So for the storage, whatever you have, you're kind of changing the state. So these are all write functions. And we also have some of the get functions, like it will just get the data from the storage. So this will not cost any kind of gas or any kind of transaction fees. You can directly get the data from the blockchain. So there's a function called like get market info. So with this, you can get the entire market information. So people will just pass the ID and you can get the entire market information, which has question, what's the name of option A and option B, the end time, outcome, what's the status of that particular market. And you can also add like how much balance he has and all. I think these kind of helper functions you could add on the data that you are storing in the contract. So this is the uh, prediction market smart contract. So as part of this, as you can see, I'm using ownable, which means like we are extending ownable, which means that it gives you a owner function, or the implementation would be in this particular extendable contract, and it will give you actually the owner of the contract deployer. So based on that, whenever you go here, for example, we don't have owner related variable anywhere here, but as you see, we have used a few places, like for example, this, like you can either add only owner here, sorry, only owner here in the function, or you can also define with your own custom messages. Like for example, here we have defined a custom message like only owners can create markets. So otherwise you can, if you have only owner, if you just put only owner keyword here, it will automatically check for the owner. So only the owner will be able to call this function. So that particular interface or the extension that we have done, I think that provides this functionality of the ownable contract. So this is the,
Oh, Praveen, sorry. Before you move on, we do have two questions in the chat. First one is, what do you mean by market is resolved and unresolved?
yeah, market is resolved in the sense like, so we are creating an event. So it's just a prediction market, right? So you create a question. So initially a person creates or admin creates a question. So it's kind of an open for people to vote. Maybe they can go for A or B options. And there's also an end date. Let's say like once the end date is over, now people cannot purchase or do any kind of buying or selling or choosing an option A and B. So once it reaches an end date, now for this particular event, there should be a winning answer. So because people either they have chosen either option A or option B. They put money for that particular question for option A or option B. So now finally there should be a person who actually gives an answer, or there should be a status, or there should be a stage where there's an answer for the question or there's an answer for the event. That's when we reach the third stage or the final stage. That's when we call it as resolved. So initially, by default, whenever you create a market or create an event, it's kind of an unresolved. And then when the pending state or the end date of that particular event is over, you can name it as like pending. The event is still pending because it's still waiting for the answer. So because the answer you can maybe automate, or the admin has to tell the answer for that particular question. Let's say a simple, maybe we can go through a scenario. Let's say like, will Bitcoin reach 150K at the end of this year? Let's say if this is a simple question, then maybe it could be an event for maybe like the leftover 6 months for this year. And then once the 6 months is done, until 6 months, now the event is created. Until 6 months, people can go for option A or option B. Like S, if you are thinking that it will reach 150K, then maybe people can choose yes. And if people doesn't believe, maybe they can bet on B, option B. And maybe like once we reach 6 months, that's when like the tenure is over. The event end date is over. An admin can actually look at the market, and he will update the answer or the event saying that it has reached 150 or not. So that's when you say that it's resolved. The market is resolved. Yeah, I hope the answer.
Okay, so we do have a second question from Akinimo Johnson. Please, in your ratio calculation, what is the 1E18, or is it the same with using 1 star
Yeah,
star 18?
yeah, just 10 power 18. 10 power 18. I think as you already know that there's no such thing called like floating values or decimal values. So that's why like you kind of multiply with 10 power 18. 118 is just 10 power 18. Yeah. Yeah, you kind of, because the losing shares and the winning shares, let's say if it gets a decimal value, you kind of multiply with the 10 power 18. And then you kind of here, as you can see, you are dividing with 10 power 18. So end of the day, just 10 power 18 to just have that precision, to just make sure that the precision is not lost. Yeah.
I hope that answers the question. Yeah, sorry about that. I think I missed the first part for your first question. But yeah, I think you did ask the question earlier. All right. So if there are no further questions, I think we can get Praveen to continue on. Just give it maybe a few more seconds to see if there's any other questions for the where we're currently at. Okay, cool. Praveen, please carry on.
Yeah. So yeah, I think we can deploy these contracts, and then maybe we can use these contracts. So before deploying these contracts, I think we can go through the front end as well, and finally maybe we can deploy it, and we can just see the entire flow once. So like this is the application which I created. So as I was saying, we have defined like 3 stages. Of course, I think as part of this, there are like 3 stages, like active, pending, and resolved. So whenever you create an event or whenever you create a market, you kind of maybe it'll be an active stage, and people can choose yes or no. And once they chose yes or no, and once it reaches the end date, the configured end date for that particular event, it goes into the pending state. So in pending state, an admin might have to say whether the answer is yes or no, because like he'll maybe verify with the market, or otherwise maybe you can automate the process as well. So anything is fine. Like maybe an admin can manually involve in, and he can really check the question, like whether it's already reached or not, and then he can update the answer. He'll manually come in and then he'll update. Now the answer is yes, it have already hit 150. Maybe you can say yes. Once the S is chosen, it's kind of the answer is resolved. Like it goes into the result. Now the user can go in and then he can claim the rewards, whatever he based on the winning position that he has. So this is the like 3 stages over here. So as part of this, maybe I think we can go with this example itself. So yeah, so as part of this, I've used Web3 auth. So for majorly for the login part, maybe I'll just show the login part, and then I'll show the code for the login which I've done. Yeah. So I think I've logged in already, so that's why it was showing this. Yeah, so I'm using Web3 auth. So like I was saying, Web3 auth is MPC wallets. Like they kind of store the private keys for you. So that private key is also not stored within the same computer or the same machines. It's kind of divided into like a small shards or pieces. And maybe you can also store one of the piece in one of your devices. And when the user try to access with maybe Gmail or be it like other social media, um, so when the user try to access it, it's kind of safely gets those private key shards and then uh, build the private key in the front end. Like it's kind of on the fly, it kind of creates the private key for you. So as part of this, I just activated the Google login. But of course, you can also have various options. It also has like MetaMask, like a normal non-custodial wallets, and it also has like social media, social logins. You can also like various like Google, like Apple, all this. It has various social logins. So I'm just logging in with like Gmail. Yeah. So this is how it logs in. It'll just verify your mail, and then it'll actually get those shards in the behind scenes and finally give you a kind of a provider from those service which we are using. So for this, we first have to go to the dashboard for the Web3 auth. So this is that. So you just have to maybe search for the Web3 auth dashboard, and you have to create a project for it because we have to give this client ID in the front end. So you just have to go and create the project, like maybe the name of the project, like you could maybe select a plug and play as a product, and the platforms we are using in a web application. So it could be web application, and environments they have given like 2 environments. Maybe for the test environment, we can go for DevNet itself. So once you create this, like you get this client ID. So this client ID will be using in any of your front end applications. So once you have this, there are some configurations that we might have to do. For example, there's a domains that you can whitelist. So from front end, when you're trying to interact, you'll get like some cost issues. So to resolve this, you might have to give your a running domain or your front-end URL into this, add this, and also as part of the chains, as you can see, you can, as we are dealing with the Kairos network, the test network, you can directly go into the test networks and activate this. So this already has the options. They have already configured this. Like there's a default block explorers, there's an RPC URL. So all these details are already configured. You just have to go inside and then activate this. So if there is nothing like this, yeah. So this way, like once you have this, finally you'll get the client ID, and then there's like different type of I think the Web3 auth also have provided you various ways of integrating into different platforms. So they also gave some snippets for integrating into React.js, JavaScript, Vue.js. They gave various examples for this. So as part of this, I integrated into a basic application into a HTML and JavaScript. So it doesn't have much complicated code. So majorly it has a plain HTML and vanilla JavaScript. So we already committed this code into the GitHub. So we'll share that GitHub links as well. Yeah, so maybe I'll just go here. So as you can see, this is a client ID, which I got from the dashboard. And USDT, the contract, maybe like once you deploy, you can come and replace here. Prediction market, you can provide the USDT as part of the constructor in the prediction market. And then you can also configure that as well. And by default, without logging in, I'm trying to fetch these details. So it's kind of like I'm directly communicating with the blockchain and getting this information of all of these markets. So without logging as well, you'll be able to get this information. So to get this, of course, you can also configure RPC URL, which is a public RPC URL. So you can get these kind of public RPC URLs in the documentations. So here you can see these are like mainnet public RPC URLs. And this is a testnet RPC URL. So I've used this one. So we can also configure this. But yeah, I think we'll directly go into the connection. So this is how you can integrate the Web3 auth. So in a plain HTML, you just have to integrate the Web3 auth model into your index.html. You can just add the script into the HTML. If it's a React.js, you can actually install the package of the Web3 auth model, and then you can directly use these objects. But the implementation would be same. But there's also like they also have provided hooks for React.js, and it's even like simpler in other ways. So, but for the vanilla JavaScript, you can still use these implementations in the React.js as well. So you just initialize the object. For this object, you might have to provide the client ID, which you created in the dashboard. And you provide the network. So the network which we selected, which is a devnet. And you provide the default chain ID, which is this chain ID is for Kairos. This is a hex code of 1001. So this chain ID we have given here. And finally, these are like some configurations that you can use. For example, in this case, I've only activated Google and I deactivated MetaMask and other things. So that way you can see only Google login in the front end, but you can also activate various wallets as well in the front end. So once you have it, you initialize the object and you connect. So once you connect it, you get the provider. So this is a provider object which Web3 auth provides. And then once you have the provider, you can inject that into Web3.js. I think this is the library which I was talking about. So with this library, you can communicate with the blockchain. So this has some of the steps, like first, you initialize the Web3 object. So maybe before jumping into this, I'll explain like some of the steps which most of the libraries use, like initialization, and then how that is used for value transfers and the smart contract interactions. So like first, I think until now we have just seen how to initialize the Web3 auth. So as soon as it hits the Web3 connect, it kind of provides a pop-up, and then you select and then log in. Once that is successful, you get a provider key. provider object.
Hey,
I think
Praveen,
this.
sorry to interrupt. Can you zoom in a bit? I think it's a bit small.
Oh, sorry.
There we go. Yeah.
Yeah, so this is how you just initialize a Web3 auth object or Web3 auth provider. So you get the pop-up, you kind of select the option that you have activated, maybe Google login or any socials or any wallets that you have activated. And once you have that, you'll get the provider object. Yeah. So this is the login part. So now I think we can move on to the like how to initialize one of the libraries that we're going to use for calling the data and then interacting with the smart contracts. So I have another example. I think this one, maybe I'll explain what's the functionality of it at the end. But as you can see here, so in this example, we have used ethers.js. So like I was saying, Web3.js, ethers.js, VM, these are different types of libraries that people can use. So even Kaia chain has provided Kaia SDK. So under Kaia SDK, there is a ethers extension. So in this, there are like couple of functions that you could use. So the first one is I mean, whichever library you use, mostly the steps would be similar, but the functions are a bit different. But yeah, the first step majorly would be like initializing your provider. For example, as this is a backend application, this is like a standalone backend application. When you have these kind of standalone applications, you kind of provide an RPC URL for the provider, like a JSON RPC provider, and then you initialize this object. For this, you need an RPC URL provider. But for the front end, like I was saying, for the front end, you don't need that. For the front end, when you are interacting with the wallets or any other sources, then you don't have to give the RPC URL. You kind of get the provider from the MetaMask or uh, or like if you are interacting with the MPC wallets, they also provide you the provider. So we don't need any kind of RPC URL in the front end, like front end when you interact with any of the MetaMask or any kind of wallets. But in the backend, majorly, you first step is to get the provider. And once you have the provider, as you can see, like we can create the transaction object. Like in this case, it's just a value transfer. So you can create if it's a value transfer, then you kind of create a transaction object like this. Maybe if it's kind of a smart contract, then for smart contract, we must have already seen that for whenever you deploy a smart contract, you will have a smart contract address. And there's also something called as ABI, which is a interface for the smart contract, which will just have the functions. So we need the smart contract and we need the ABI for the function which we interact. So these two things we need when we wanted to like communicate with the smart contract. So when you have a smart contract, you can actually inject that smart contract address, the ABI, and then the providers, you kind of get the contract object, and then you can maybe create a transaction, or of course you can also directly call the methods as well in the contract, which I'll show you. But once the transaction is ready, maybe you can do a sign transaction, and then you can actually send the transaction. So as part of this sending transaction, I think I've used a fee delegation server, which I'll explain you. But this is a way of sending transaction. Yeah. So this is also a sending transaction. So here, as you can see, first is like having a provider, which is like this, and then maybe like creating your transaction objects. And then like once you have the transaction objects, you kind of maybe do a sign and send. Of course, there's also directly a send transaction, which you don't have to do multiple steps of sign and send. There's directly send transaction, which where you can pass the transaction object, which will directly send the transaction to the blockchain network. So these are like some of the steps. So I think most of the frameworks will use similar steps, but maybe the functions might be a bit different. So in this scenario also, in this also, I think we can go through that. So here I have initialized the Web3 object. As you can see, I've used a provider. So I think maybe you can just ignore this, but yeah, Web3 instance, I have forwarded the provider into this. So this provider I'm getting from the MPC wallet itself. So once you have the provider, there are like some of the functions like .get accounts. When you say this, you'll get the list of all the accounts, and 0th account would be the first connected account for this account.
Sorry, Praveen, before you move on, a few questions from chat. I'm not sure if you've already shown this, because I did step away for like a minute to go get a bit of water. First one is, can you please show the process from your code line? I'm not sure what you're referring to because this was sent about 10 minutes ago. And then the second question I think you can answer a bit more is it means we are using Web3 auth because of, are we using Web3 auth because of the Google for account abstraction instead of Ether.js for React?
Yeah, Ether.js you can use. Uh, Ether.js by default, it doesn't provide socials. I mean, these are like multiple options. Like I was saying, right? Like libraries, you can use different options. So it's up to your use case. Like, yeah, 1 second.
Yeah, so hopefully that answers your question. I'm not sure about the question about showing the process for your code line. Maybe you can expand a bit more which specific one you were referring to.
Yeah. So for example, if you use Ethers.js, then you can interact with the wallets. So for example, in this case, maybe any wallet, maybe Rabbit wallet or MetaMask or Kaia wallet. So so Ethers extension can interact with the Kaia wallet. Ethers can interact with MetaMask or Rabbit. So and then Web3.js. So all this can directly interact with the wallet which is um, sitting on your Chrome extensions. So, but for example, let's say you want to interact from your mobile, then you might need a layer for that implementation. So that's why like all these companies like Web3 Auth, Privy, so these are like different companies which does the account abstraction, and they provide various services like social logins. They also provide a feature with Wallet Connect where you can directly connect from your mobile. They also provide a basic wallet connections like by default, whatever it's there in the browser, you can also directly connect to it. So Web3 or mostly, I think when you're kind of using mostly a production-based applications, people can go for Web3 auth, which is more flexible than using an individual Ethers.js or even all this individual libraries. I think that will be even more useful, like Privy and all of these companies.
Yeah, so hopefully that answers. Oh, he answered the question earlier. Okay, cool. Sorry about that. Yeah, I kind of assumed. All right, so yeah, I can go back. Thank you, Praveen.
Yeah. So here also, I think we just initialized a Web3 JS like Ethers. So here, as you can see, majorly we got the provider, and then once you have the provider, you can maybe when you are asking for Ethers, I was saying uh, for the initial login for the Web3 auth, why we are using for Web3 auth is having that social layer upon it. But of course, if you use Web3 JS or Ethers JS, you can directly interact with the MetaMask or Kaia wallet. So that's the only difference there. But once you have the provider ready, you can always inject that into a Ethers or Web3. And then if you're comfortable with the Ethers JS library, because every library has their own set of functions. I mean, people cannot learn everything and then be an expert for every library. So if you're very comfortable with Ethers JS or VM or maybe Web3 JS, if you're very comfortable understanding all the functions, how to call that function, so if you're very comfortable based on that, I think once you have a provider, you can directly use that provider for whatever library you have. So, so now you got a Web3 instance here. So as you can see, like in our application, we before login itself, we got all the list of the markets. So when we go inside, I think sorry. So we got all the list of markets. So there's a function here for load markets. So yeah, one sec. Yeah. So, like I was saying, I think if you want to interact with a smart contract, I think this is the flow that you will follow. So you have a Web3 instance. I think this is just a Web3, same Web3 instance. So you have a Web3 instance, and you actually initialize this particular function with ABI. For example, in this case, as you can see, I'm initializing a USD contract and then a prediction market contract. So for example, if you are going with for a prediction market contract object that you want to create, then you kind of pass this parameters into this particular class. The contract class, you forward the prediction ABI, prediction market ABI, which you'll get from the Remix IDE. I think I'll just quickly go and deploy and then modify that. But you can get the ABI from the Remix IDE or Hard Hat or any kind of frameworks. You can place the prediction market ABI, and then whatever the contract is deployed, I think that contract address you can mention here. So once you have that, you kind of have a contract object. So with that contract object, I think you can call the functions which are there in the contract. So, so as part of this load markets, as you can see, so we are calling the market count. So, so in our particular contract, I think we already have market count. So by default, as this is public, there's also a default getter function. So you can have this market count. You can directly call this market count. And then, like I was saying, there are two types. Like one is when you wanted to make a state change, when you are doing a transfer or when you are trying to make a change into the storage, then you might have to pay the fee. But there is another way, like when you are getting the data, then you don't have to pay any fee. So as part of this, you are just getting the market count data. So here you have to append with this call function. So when you do this, you directly get the value of market count. So, and then we also have a function for get market info. So which will give you all the details of the individual market. So we are looping all the market count. So we have the total markets. You are just looping it and then getting all the market information. But is this scalable? I think we don't have to do this way. We shouldn't do this way. When we have a lot of markets, then you kind of rely either maybe you have to store all this market, at least the market information maybe in your database or anything, and then maybe listen to an events, or maybe you might have to rely on any third party companies who provide you an API for getting these kind of market information, because every time you cannot like hit the data and hit the smart contract and then loop all the way to get all the market information. So I think this is generally a bad idea, but for small use cases I think this will work. But as the market grows, you cannot like you cannot sit and wait for getting all the data. Maybe you might need to provide a caching service or but if you have to get a live data, then you also have to listen to events, but and also maybe you can go for any third party APIs. But this is one of the simplest way for less data. As we already have the market count, you get the market count and then you can loop the entire market count, because the market counts or the market IDs are assigned based on the incrementing counter. So with that idea, I think we are just looping it and then getting all the market information. And then we are rendering all that market information in the UI. I think, yeah, this is the function which you might need to know. I think the other ones, I think majorly the claim, and then I think similarly we already have seen, and then finally how to place the bet. Yeah, majorly for placing the bet, people will forward the market ID and then which option he might have to put in. So in this case, we are majorly putting the bet with the help of USDT coins, which is like tokens. So these tokens, you might have to, first of all, this particular bet, whenever it executes, the smart contract has to deduct that particular amount from your account. So for it, you have to give control to the smart contract. So that's the first step. So you need to give control to the smart contract, because the smart contract is the one who is executing the USDT or the token transfers as part of your bet. So first, to give the control or give the access for the smart contract, you might need to actually provide an approval. So the first step is kind of an approval. You need to give approval to the smart contract. As you can see, like we are giving the approval to the smart contract for that particular amount. So this is the approval step. And once the approval is successful, that's when the buy shares happen. So that's when the smart contract actually transfers the amount from your address, because you gave an approval for the smart contract. That's when from the prediction market, it kind of detects the USDT from your account, and then it will actually put into the option A. I think these are like two-step process that happens for the betting. So I think these are like major functions. I think when winning, I think it happens in a similar way. But yeah, as you can see here, we don't have any call method, but instead we have send method. So because here we are actually making a state change, because when you have an approval, it's kind of you are trying to change the state or give control to another person where the data or the storage changes. So that's why like you have to go for like send function. And here as well, like when you're doing a buy shares, it's kind of you're sending a tokens and then making a state change in the smart contract. So here also you call that function, you send the parameters which are required for the function, and then you also call the send function. I think this is the entire flow. I think we can directly follow the deployment, and then we can use this contact IDs into our example. So first, as part of this, you can go for USDT deployment, because we are using these tokens into the into the prediction market. So first you can deploy this. So there's this final Kaia option which will help you to directly connect with Kaia wallet. So how do you get this? Like you can directly either go into plugins and then search for Kaia, and you can find the Kaia like this. Otherwise, you can go to a wizard.kaia.io and you can directly open in the remix. So as soon as you open the remix, it'll activate the Kaia plugin, as you can see in the top. So this is just activated, and then finally you'll end up in this. You'll have this option where here you have to select Kaia wallet injector provider. So and the network here is shown here, which is Kairos, which is a test network. So here we are deploying native USDT. So as I was saying, I think as soon as we deploy this much number of tokens is located within the same contract itself. So the people can actually go and claim the tokens. So yeah, so we already have deployed it. Sorry. So now we deployed this contract, and now you can deploy the other contract, which is the market. So you have to go and select this. And as part of the constructor, you have to provide what's a betting token, which is our USDT. With USDT, people gonna buy the tokens. So here also you make sure that it's like connected to Kaia wallet, and then you deploy. So now you have this. So we can directly go here and then create a market. So before this, we can configure these details into the application. So prediction market contact address, you can copy it, and then you can replace here. So you can directly go here, copy this prediction market, because we need the contact address, and we also need the ABI. I think I'll just show the ABI. So you can directly go here, prediction market, and then you can also go to the native USDT, and then you can copy this address. So we are also using the ABI. So I've used at the end of here, I just configured here, but you can get this ABI. ABI is just uh, it's just an interface. It just has the functions and then what kind of input you are forwarding, and then the output structure. So mainly it has the functions, what's the type of it, and all of this. So these ABIs I've configured here. You can get this ABI of USDT and the prediction market, in here, like you can directly go to the Solidity compiler, and when you have the market selected, you can directly get the API. So for example, I just copied this API. I'm just putting it here. So this is the prediction market API. Yeah, so you can see we have all this claimed and all these functions market created, all these events. So similarly, I think, yeah, if you want the USDT API, you just switch it, make sure it's compiled, and then your API will be ready here. I think I can just copy the API there. So this is another API. So you just copy this. I mean, it's already there in the code, so you don't have to copy. But whenever you're creating your own contract, then you kind of have to copy this into your code, because, or at least a subset of it. You can either copy the entire function, entire API, or let's say you are only interacting with maybe 4 or 5 functions. Then you can only copy the subset of those functions as well. So I've already copied this, and the application is running now. So as you can see, we don't have any events right now. So you can directly go here, and then as part of the prediction market, you can go and create a question, maybe like, will Bitcoin hit maybe 150K in 2025? Option A, I think these are just strings. You can just provide yes and no. Duration, maybe these are in seconds. You can just give like 60 seconds within 1 minute itself, and then make a transaction. Yeah, so this market is created now. I think I can just go here. Yeah, as you can see, we were able to see the market because we were pulling it based on the market ID, and we are looping all the market ID related information. So now to buy, you might need to connect your wallet, because that's when like you have to pay your tokens, and then you're putting your tokens inside. Yeah. So currently, as you can see, I have some balance of Kaia. So if you don't have it, you just copy here, go to faucets, like faucet.kaia.io, and then you can put your address and then claim it, so that you will get the faucet balance, because whenever you're doing a transaction, you have to get the money. And then USDT, we have a claim function here. So the claim function, as I told, all the money, all the tokens which we have minted is present within the contract itself. So anyone could come and these tokens. Part of this example, people can come and claim here. So now, whenever I'm trying to interact with a blockchain, I already have Kaya native fee, because if I need to interact with a smart contract, I will have to pay the fee. So I already have Kaya to pay the fee. And for betting the tokens, so I'm betting this USDT tokens. So I'm putting that money here. I think maybe I'll just put like 10. So it's kind of approving and then placing a bid. I think maybe like this is already expired. Yeah. So we just gave 1 minute. Maybe we'll create another event. Yeah, maybe say this 60. As soon as you have this. So now I think you can just connect to your wallet. So we already have our balances. Well, I think maybe I'll just place like 10. So like I was saying, like when you put the token, and then there'll be the flow. So for this, you already have put like 10, and then let's know I'm putting like 20. And here, like, yeah, multiple users could interact with these contracts. So now, as we have only one user who is on yes, and there's like one user on the buy, and let's say like if the first option 1, and then maybe if the admin chooses the first option as the final answer, then all the money of the losers part, the losers, let's say if the admin selects yes as the answer, all the money of the losers get to the winners, which is yes. So I think this must have gone into the resolution. So as you can see, yeah, this is the one. So it's still waiting for the resolution, which means it's waiting for the answer. So which is the final answer. So as part of this, maybe like, yeah, we can manually do via remix or anything. But of course, it can also be done maybe through an UI as well. Maybe they can be an admin role, and then you can provide a answer button here, something like that. So now I can come here and then resolve the market. So for resolve, the ID is 1. So I'm showing the ID here. And then the answer, I could say like the outcome is 1. 1 is the S and 2 is the no answer. Yeah, so once this is done, it should go into the result. So now the user can actually claim the amount. So as you can see, USD, I have 970. And if I win, I should get all the 30 because I get the money which I invested and also get the money from the loser. So it's kind of like playing. And then when you refresh, yeah, you get the 1,000. So this is the entire flow. So the things which you could change is, for example, if you want to provide some kind of as an organizer, maybe if you want to provide a trial period or some kind of an incentive for the user, maybe when actually resolving the market, maybe you say that I'll provide the fees instead of the user. Because now, for example, like now if you go into the Kaia scan and if you see the transactions, I think you should be able to see the fees of how much that gap paid for the transaction. So I'll just switch to the Kairos. Yeah, so this is the latest transaction. As you can see, it's 0.001 transaction fee. So as part of this particular smart contract execution, the user have paid this much of amount. Let's say like if the organizer itself wants to bear the fee instead of the user, then there is a feature called fee delegation. I think this would be the final topic, which is fee delegation. So in Kaya, in the protocol level itself, there's a feature called fee delegation. So let's say there's a user and there's an organizer, and then when the user interacts to the platform, if the organizer wants to pay the fee instead of the user, then I think the user can actually do the signature, the signing of the transaction, and he can forward the signing of the transaction to the service provider itself, and service provider behalf of the user can perform the fee delegation, so he can pay the fee instead of the user. So this kind of feature is already, and then finally can transfer that to the Kaya blockchain. So this feature is already there within the Kaya blockchain itself in the protocol level. I think I'll just show a quick example for this, and maybe if you want to improve the application, and maybe if you want to use in enterprise applications, then you could plan something like this. So maybe I'll just show in snippets. So I also attach this fee delegation snippets in the code base. So as you can see here, there's a sender and the receiver. There's also a fee paying server. So this fee paying server could be another application, or you can configure private key and then you can pay with a different account. So maybe I'll just show two ways of paying the fee. For example, as you can see here, maybe I'll just comment this out. There's a fee payer wallet. Let's say like there's a different private key as part of the fee paying. There's a different private key. So that particular account can pay the fee for the sender address, for the sender transaction that user have done. So this way you can maintain two different addresses, One is maybe like normal users, and as an organizer, you can have your own private key, which you can actually get the signature of the user. So once the user gets a transaction, once the user builds a transaction, he can actually do a signed transaction, and that signed transaction information can be forwarded to the fee payer. So fee payer would pay the fee for it. So I think we'll do this transaction quickly. So this, I think this is just a plain Ethers.js. As you can see, it's a Kairos RPC, and then there's a sender wallet, which is initialized with the sender private key. And then sender could actually prepare the transaction and then sign the transaction. This transaction string, he can forward that string to a fee payer. So this particular piece can be a different server as well. Like I was saying, maybe currently we'll put here, and then we'll try to execute this. And also I'll show you like how this is different with in the Explorer, how does it show? So when you execute this, so this is the final result we got. Maybe when we go to the transaction. Yeah. As you can see, we have a new field called fee payer. So all the fee that is paid, this transaction fee, is paid by this particular fee payer field. So even though currently, as part of the example, I've configured the same address, but you can configure any private key that you want. So, so for the scalability and for the production grade, what people does is they'll host their own backend with this logic of getting the transaction from the user as an API, and then they'll perform the actual transaction. So in this example, as you can see, there is a fee payer server, which is already deployed for the Kairos, and you can forward this particular signed transaction information to this fee paying server. And then maybe like we'll try to execute this, the same transaction. And we can see that fee is paid by someone else. Yeah, looks like there's some network problem, but yeah, I think we have the transaction ready now. So as you can see, the from address is 0x6C and the fee payer is 0x996. So a sender address, a normal user can initiate a transaction, and that signed transaction, initiate a transaction and then sign it, maybe through MetaMask or maybe through his private key. And then once he gets the signed transaction, this can be forwarded to the fee paying server, which can be a third party company, or it could be an organization or anything. So, and then he could pay the fee. So this kind of scenarios are majorly used maybe for giving a kind of incentives to the users, maybe like a free trial period for 30 days. So where users doesn't have to pay any money and the organization bears it. Or maybe when they are like some kind of incentives that you kind of promote your particular product, then people use these kind of services. So I think like, yeah, this is a final final topic of this entire session. And then as part of your exercise, so now we have seen the prediction market where there are a couple of markets that people could create, and then people can do a buy and sell. Similarly, I think as part of an exercise, you could create a simple voting Dapp. So it's just an voting application. So people can create a voting event, like there could be multiple voting events, and as part of each and every event you can register a couple of candidates. So registering candidates could be via the addresses and maybe the name of the candidate, and there will be a end date for each and every voting event. And you can also have maintain some voting related information by maybe like how many total voting that you have, and then how many people participated as part of the event, and as part of the total market, how many voting events that you have created. So these kind of stuff. And once the voting end date is over, I think finally the winner will be announced or shown in the UI for each and every voting. I think this would be a simple voting application that you can actually work on. You can deploy the contract on the Kairos test network. Maybe if you want to go with the Remix ID, you can go through, or if you want to explore other frameworks like Hardhat, also you can try out. And from the front end, if you want to go for Web3, like I was showing Web3 auth, you can try out, and there are like lots of other account abstractions. Also, a normal Web3 JS or Ether JS communication with a MetaMask as well. You can also plan that as well, like any form of login way or communicating with the blockchain. So you can follow any of those different ways of communicating with the wallets or socials. I think this could be the exercise that you can plan for. I think that's all I have. Now, do you have any questions?
Yes, hi everyone. I am back. For those of you who are, you probably already know who I am, but I'm the one who's managing this whole bootcamp sessions in terms of all the logistics and stuff. So yeah, essentially, do we have any questions for Praveen here? We do actually prefer it if you can, to ask your question live. There is no need to turn on your camera, although it is encouraged. If you are brave enough, in terms of to ask a question live, I think that's very much preferred because we're able to give you direct feedback and you're able to sort of ask follow-up questions on the fly. So yeah, probably give it about a minute or so before we move on. Obviously, you can type in chat as well. That's also fine. Uh, but yeah, in the meantime, yeah. So I do have a question, Praveen, for the class. Right before we move on, when is the? Can you go back up to the assignment exercise for a bit?
Yeah.
Yeah. So when is this exercise due?
No, I think if let's say like so because maybe today and tomorrow we have a same thing. So maybe we don't I don't have a plan of having exercise for tomorrow because that is also a different Dapp. So it's just the same different architectures of Dapps and making use of an APIs. So I think maybe you guys can take at least maybe like 1 or 2 weeks should be fine. 1 week should be good, I think, because we already have examples for the current project. So yeah, you can target for maybe 1 week, 2 weeks should be good. 1 week should be good.
Yeah, so especially because next week we don't actually have any lessons, because as I mentioned at the kickoff, that week is actually the week of ECC, and we're also using that week to help evaluate, who has the attendance requirements for hackathon. So for those of you, before we move on to the questions, just a quick housekeeping. Those of you who are here, I think about 16 of y'all that are here. I believe that most of y'all here are actually able to participate in hackathon. I will double check. So yeah, if you have any friends or whoever uh, who is missing lessons, because there are a few people who are missing, maybe as of this session at least, maybe 1 or 2 sessions before they hit the 90%. So yeah, I believe Praveen just shared the code based now. Sorry, let
Yeah,
me reshare that because you only shared it to the participants.
yeah. Please share in the others.
Yeah. I'll also share this in the Discord channel, a Discord, wherever it is, right? In addition to the recordings as well as the slides for this workshop lesson. Yes. So yeah, do we have any other questions?
Yeah, I think I saw a few questions like the ABI. I think yeah, the ABI. Where did we configure in the front end? So for example, like here, I already configured the ABI here at the end of the code, but yeah, it's available for the code that wherever we are initializing the contract object. So the API you can like get from the Remix ID or like hard hat anywhere, and then you can use it at the front end. This is just a
Okay.
array.
Yeah, so we do. Hey, oh, what happened? I thought we had one brave soul who was going to ask the question. Oh no, I thought we had one person who was going to ask
Yeah.
the
Paul, I
question.
think there is
Oh,
a
I think
question.
yeah, they
Paul.
raised a hand. Yes, I will allow you to speak. Like I said, we do encourage you to turn on your camera just for ease of use, but there's no actual need to. Okay, so I'm gonna allow you to talk in a bit. Okay, you can unmute and just ask your question.
Hello, can you hear me?
Yeah, hello. Yeah, I can hear
Yeah,
you. Yeah.
yeah. I wanted to ask about is concerning the ABI
Mhm,
because I actually dropped my hand because of what I saw just now.
mhm,
In the case I'm writing a contract that I'm actually working on a project that requires up to like writing like about four contracts for that particular project, and I have to use the ABI for each to interact with my front end. I have not done something like that before. So, but I had a current project currently that I'm building, and I'm building it on Kaia, and I'm writing like the contracts to execute that project will be up to like five. So I'm already on the third one. So I'm already having issue ahead of time because how to interact with all the ABIs all together
mhm.
is a
All
concern.
together? Yeah, all together in the sense, yes, the simplest way. The simplest way would be to initialize all the five objects. But ABI, do we need to provide all the ABI? Because like, are we calling all the functions of that ABI? Let's say like if the ABI is very huge and out of that ABI or out of that entire smart contract, let's say you are only calling like transfer function or like two or three functions. You don't need to plug in the entire ABI. I think you can just plug in the functions, whatever it's required. And like in my use case also, I'm using two ABIs, right? Like USDT and then the prediction market. So I kind of initialize two ABIs. So we have to initialize the objects for all the ABIs that you're going to use because you are interacting with it. But do we need to provide an entire ABI? I think we don't need to. I think you can just cut it down to whatever functions is required out of that entire smart contract. If you're interacting with one or two functions, just provide that two functions within the ABI. And you can have only one ABI with maybe, yeah, one ABI with let's say you are saying you are dealing with five contracts, right? Like you can have only one API with five different contract related functions, and then you can plug in the same API. That also should do. Yeah, I think that should do. But like I
So,
was saying, if you separate, I think it will be more easier for you. But like I was saying, you don't have to use the entire ABI, like events, because all this ABI has the events and all the maybe like all the basic public functions related getter functions will be there. So you don't have to, if you're not using all of that, you don't need to import all of that. You just import whatever it's required for you.
okay, thank you.
Yeah, sure. Thanks.
Okay, thank you for the question. Do we have any other questions? Because we do have a bit of time. We have maybe 12 more minutes.
Yeah, I think Paul has a question.
Ooh,
Paul Paul asked a question, is it only for the KVJS that used to enable the fee delegation? I think now uh, it's a KVJS is deprecated, kind of we are not maintaining it. So we created Kaia SDK. So in the GitHub repository, as you can see, there's a Kaia SDK. So this Kaia SDK has extensions for Web3.js and all VM extension and also Ethers extension. So you can use any of these extensions to provide the fee delegation. Because the fee delegation has a different type that only Kaya supports. So for that, I think we might have to modify it a bit on our side. So I think this SDKs would be helpful for you to communicate or make use of those features. And also maybe from the front end, if you are interacting with any kind of wallets, and if you are expecting fee delegation, then from front end you have to use one of these Kaya SDK related SDKs. And for the wallet from the front end, for the wallets you might have to go for Kaya wallet or OKX or BitGet. So only these three wallets provide you a fee delegation from the front end. Yeah, I hope that answers.
yeah, I hope that answers your question. Yeah. So I'm gonna give it maybe another minute or so to see if there's any other questions. or if anyone else is brave enough to ask their question live as well, I think, as I said, we do very much prefer it. So yeah, Praveen, I think you need to change your
Oh, sorry. Is
to
it?
everyone to, because you're currently talking to hosts and panelists only, so you need to
Oh, is
change
it?
it to
Sorry,
add
sorry.
everyone and then you respond.
Yeah,
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 sorry,
sorry.
it's been a while since we've all used Zoom,
Yeah.
I think.
So I was saying that API, if you are trying to generate from the Remix ID, then it's kind of, yeah, you have to compile. Only when you compile, you get the ABI of that particular contract. For example, when you switch to this contract and compile, because it's kind of you're compiling USDT, and you get the ABI of the USDT. Like, yeah, this is the ABI of the USDT. So similarly, when you want the prediction market related one, then you might have to compile, like compile in the sense, if you just check the auto compile, it will automatically do, but the ABI will be generated here. But if you go for, yeah, any kind of hard hat or any kind of frameworks, I think when you compile, it will automatically generate the APIs. Yeah.
Yeah, so I think as there are no further questions, I think we can end it here. Just keep in mind, I've already said, I believe that the Zoom links and all the passwords, everything have already been sent out to your emails. So just if it hasn't, just look through your spam folder, I think. I already sent out EDM already this morning, or like early this morning at least. So yeah, if there's nothing else, then I think we can end it here. I'd like to thank everyone who has attended the session for attending live and asking your questions. Yes, and yeah, we'll see you all tomorrow at the same time. Praveen again will be presenting on the intermediate Dapp. I hope everyone's excited for tomorrow's session. Hopefully this session wasn't too draggy or too a bit it did go a bit long considering the last two sessions were about an hour, but I think it was fine because we had a coding demo, right? So as always, the recordings and the slides should be up very shortly. Do give me a bit of time because I guess I am one person. So yeah, and I would recommend everyone to review the slides and go through the exercise, at least try or review the slides before going to tomorrow's lesson. I will have it up shortly, or by early tomorrow, I think. So yeah, and I do apologize, as I mentioned before, for the back-to-back lessons. I think we have lessons on Monday, Tuesday, and Wednesday. That is mostly because we have our regular town hall that happens at the end of every month, at the end last Thursday of every month. So, and if I put a meeting on Friday, nobody's gonna come. Let's be honest, it's Friday night, right? So yeah, that's why we have Monday, Wednesday, Monday, Thursday, Tuesday, and Wednesday. So yeah, if there's nothing else, I'd like to think, I said, any parting words, Praveen?
No, I think, yeah, tomorrow application also kind of, I think we'll be mostly using the Kaia SDK and then Kaia Scan APIs. So I think, yeah, mostly this two will serve or will help you to just understand the flow of Dapps. But there are many ways of implementing and using the combinations of this. But majorly, I think this would give you an idea of building the entire application end to end.
Okay, yeah. So yeah, thank you all for coming to this live session. And yeah, I hope that we will see you all tomorrow again. Okay, thank you everyone. Bye.